Good morning, Algebra 2. We're going to jump into lesson 42. This is a bit more on probability, and hopefully I can shed light on where to find these buttons on a calculator or Desmos. So hopefully you're watching. So let's go over the three terms. There's the factorial, combinations, and permutation. So I've listed those at the top. Now, factorial, in English we call this an exclamation point. In math, it's called a factorial. And so that means that 5 factorial represents 5 times every number below it. So 5 times 4 times 3 times 2 times 1. 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So something factorial means that number times everything below it all the way to 1. Combinations. Combinations are, well, you know what, I'll start with permutations. This is the button. These both represent the formula and the button in your calculator. And I'm going to start with permutations, where N represents your total objects and R is number taken at a time. And permutations are for things where repetition is not allowed. So no repetition. That's not how you spell repetition. Let me fix that. Oh my. No rep. This is an E-tition. There's no repetition. And it's also used in place where the order of things does matter. Now, I believe they gave you a formula in the book. So NPR equals N factorial, your total, divided by your total minus the objects taken at a time, factorial. Now, I will show you where this is located if you have Desmos. Well, everyone does because it's a student iPad, or if you're using a calculator. Combinations are where, the same thing, this is still your total. This is our objects taken at a time. The difference is repetition is allowed. And in this case, order does not matter. For example, cards. Doesn't matter what order you receive those cards in. Or permutation would be something like a password. It matters what order you enter your password in. So permutations are, or how you spell your name, right? Those are permutations. A combination are things like cards, a lottery. Doesn't matter what order you picked the numbers, just that your numbers are called. So the order of these objects does not matter. The book also gives the formula for this one. If you're interested, or if you don't have a calculator near you, it's the total, or N factorial, divided by R factorial, and then the rest is the same as the other one, N minus R factorial. Now let's go over the fact that all of these are on Desmos. Okay, and I believe they're listed under the word probability. So I don't have Desmos on my computer, but I sure do have it on my phone. It's a free app. You guys have it on your student iPad. So if you go to functions down below, I believe it's listed under stats. Let's see if I can. There's NCR right here, and here's NPR. And I would guarantee that your factorial symbol is when you hit ABC, there's the factorial. So in Desmos, under functions, and then under stats, you'll find NCR and NPR. If you click the ABC button, you should see the factorial. Okay, so I'll show you this on both. If you're using a scientific calculator like the ones in my classroom, Then you have to hit there's a button that says PRB. If you hit that button, then all three appear, the factorial, the NCR, and the NPR. So it just depends on what you're using. I would suggest Desmos since you all have it. Okay, so I'm going to jump into lesson practice, which is on page 309, I believe. I want to make sure I have that correct. I have the book in front of me. Hopefully you do too, and you're following along instead of just staring at the screen or playing this in the background. So lesson practice is on page 309. We'll jump in with part A. Part A asks us to evaluate 6 factorial. Now I'm going to show you both. You could do one of the following. You could just enter 6 times 5 times 4 times 3 times 2 times 1. And you really don't need to enter times 1, right? So I like to hit as least buttons as possible. So 30 times 12 times 2. And my calculator wasn't on, silly goose. And so I like to hit the least amount of buttons as possible. That gives me 720. If you want to use your calculator or Desmos, I would hit 6 and then I would click the ABC button and then click Factorial. So if you're using Desmos, I'm going to go back to, I'm going to hit 6. You can't see that because of the glare, and I really apologize for that. Hit ABC, hit Factorial, and it appears in the bottom 720. So either way, you should end up with 720. All right, part B in your lesson practice has us evaluate 6 factorial divided by 4 factorial and 6 minus 4 factorial. And I'm going to go over how to enter this in your calculator because you will need to know how to deal when you have more than one. So I'm going to simplify this first. I'm going to enter 6 factorial fraction bar. Now notice it's super important. I now use parentheses 4 factorial times 2 factorial. Okay, now I didn't write these parentheses because I think it's fun. You have to enter parentheses because your calculator does something called order of operations. And if you don't put parentheses, then it will divide these two and multiply by 2. It won't divide by the product of the bottom. So you have to enter the parentheses. If you're not listening to that, then you can get it wrong if that's your choice. So again, in Desmos, because that's where I'm going to enter, I already have 6 factorial, so I'm going to go back to ABC. I'm going to go to divide. I'm going to use parentheses, and then I'm going to hit 4 ABC factorial, go back, times 2. Now, do I need to enter factorial? No, because it's just 2 times 1, but if you like to be consistent. And notice the answer is in the bottom right, 15. Okay, so that is it. Part C says find the permutation of 7 objects. Now I want you to know that permutations are very similar to factorials. A permutation of 7 objects means I have 7 spots and I'm trying to put them in order. So it would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Or I could enter 7 factorial. Or I could enter, I have 7. It says permutation, so P, and I'm doing all 7. It didn't say I'm only taking 6 at a time or only taking 2 at a time. So I could enter all of these and they'd all give me the same answer. So 42 times 20 times 6. and that gives me 5,040. Or I could enter 7 factorial, so 7 probability factorial. Hit enter and I get 5,040. Or I could hit 7 and then go to probability, hit NPR, and I'm choosing 7, and I still get. So either way that you enter it, your answer is 5,040. Next one. Now I'm going to, part D says find the, and then we're going to practice a little bit for the next one. Part D says find permutation of 12 objects taken 3 at a time. And I'm going to show you 2 ways to do it. So this says permutation. So I'm going to use a big P. 12 objects, that's my total. So that should go here. So 12P, and I'm taking 3 at a time, so the smaller number goes here. What? So in a calculator, I would hit 12, then the NPR button, then I have to hit 3, and then I have to hit enter. So let's say you're using Desmos. So I'm going to clear this one. I have 12. Hope you can see that. Then I'm going to go to functions, and under stats, here's NPR. Oh, Desmos is different. Hold on. In Desmos, you hit 12. I'm going to guess comma 3. Yep, okay. So this is in a scientific calculator. In Desmos, you have to hit NPR and then 12 comma 3. That's Desmos. And I used this method, and I got 1320. So that is how you would enter it in Desmos. Another way of doing it, if I'm taking 12 objects taken 3 at a time, I've got 3 spots to fill in, but I have a total of 12 times 11 times 10, which would also give me 1320. So either way you do it, you should get an answer of 1320. Now before we jump into the next part, I want to go over a few things with you because these are the ones you'll see. So this is not in the book. How many ways can I rearrange? And these are very similar to the ones on your test. How many ways can I rearrange the letters in the following? And I shouldn't do letters because lesson practice has letters. In Michelle. That's my first name. There are 1, 2, 3, 4, 5, 6, 7. There are 7 total letters. So on the top I put 7 factorial because I have 7 spots where I could put a letter. On the bottom I have to divide by any letter that repeats. So in my name, I have 2 E's. So I'm going to divide by 2 factorial because there are 2 E's. And so that's what I'm entering, 7 factorial divided by 2 factorial. So if you want to use Desmos, totally fine, because that's what you all have. So 7 ABC factorial. Go back to operations, divided by 2 ABC factorial, and I get 2520. All right, let's use Arroyo's name. All right, Arroyo has 1, 2, 3, 4, 5, 6. There are 6 letters. So on the top I put 6 factorial. Now I have to divide by any letter that repeats. There are 2 O's and there are 2 R's. Now, I just covered this. If there's more than one thing in the bottom, when I enter this, I'm going to divide by 2. And I'm going to put multiply. Now let's talk about 2 factorial equals 2 times 1. So I can just put 2 because 2 times 1 is 2. So I'm going to enter it 6 factorial divided by 4 because 2 times 2. Okay, so Desmos. Sorry, my phone locks all the time. I'm going to hit numbers 6, ABC, factorial, go back, divided by 4, and I get 180. Last one, let's talk about Mrs. Navarrete. Woo! She has a lot of letters in her name. So let's see here, 3, 6, 9, 10. However, she has several repeats, right? There are 2 A's. There are 2 R's. There are 2 E's and there are 2 T's. So I would have to do 10 factorial divided by 2 times 2 times 2 times 2, or 10 factorial divided by 16. Okay? So if I enter that, 10 factorial divided by 16, there are still 226,800 ways that you could rearrange the letters in her name. So let's jump back into lesson practice. If you get problems like that, remember to divide by the repeats. So we are on to the problem E, which says how many ways can you arrange the letters in Ohio. So you could pause and try this, but there are 4 letters, but there are 2 O's, so I'm dividing by 2 factorial, but that's just 4 factorial divided by 2, and I'm just going to do that by hand. 4 times 3 times 2 times 1 divided by 2, so that's 12 times 24 divided by 2, 12. All right, part F asks find the combination of 7. Whoops, no, it said of 10. Sorry, the total was 10. Of 10 objects taken 7 at a time. So this is your total. This is the smaller number, but they are talking about combination. So you shouldn't be like, what button do I use? It's right there. So 10, C, 7. So in Desmos, hit stats, then hit NCR, and then parentheses will pop up and you'll put 10, 7. Okay, so in Desmos, and hopefully you're practicing this and not just listening, because you won't remember if you just listen, but if you're an active participant, meaning you're going into Desmos and you're entering it, you're more likely to remember this for study guide, tests, and homework. So go to Functions, Stats, NCR, you hit 10, 7, and it pops up for us 120. So sorry, you have to hit Functions first. Then stats, then that, and I got 120. All right, part G says that I have 4 salad dressings. That is not how you spell dressings. What am I doing? 4 dressings. And it says that I have 4 vegetables. It says that I have to choose 1 dressing and I have to choose 2 vegetables. So how many different combinations of a salad can I create? So I'm going to do a combination for dressings, and then I'm going to do a combinations for veggies. So I have 4 dressings to choose, because it doesn't matter what order you pick, that they said I have to choose 1 of them. And, so I'm multiplying, I have 4 veggies, but they want me to choose 2. So I'm going to enter this in my calculator, and it doesn't matter if you use Desmos or not, or if you use a different calculator. I'm just going to edit this last one I entered, so 4, I have 1 dressing to choose from, times, I'm going to go back to functions, stats, combination, 4, 2. So I have 1 times the other, and I get 24. So in Desmos, I entered NCR 4, 1 times NCR 4, 2, and I have 24 choices of salad. H, there are 52 cards in a deck, and it says how many 4-card hands are possible. Now, when I'm playing cards, it doesn't matter what order I draw them in. Like, let's say I pick the king, and then I draw the 10, and then I draw the 4, and then I draw a jack. It doesn't matter what order. So because order doesn't matter, and I also remember it because cards start with a C, I'm using combination. My total is 52, but I'm choosing 4. And so that is what I'm going to enter. Into Desmos, I'm just going to enter the last one I'm going to edit the last one we did. And I'm going to put 52, 4. But my fingers are so big. And I get 270,725 possible 4-card hands. All right, part I. How many ways can they be picked? How many different ways can 4 cards be picked from a standard deck of 4 cards? We're going to skip I. J. In how many ways can 3 blue, 2 red, and 5 green be distributed to 10 students? Now this one is hard, okay? I have 10 students. Think of this as like the Navarrete and Arroyo problem. I have 3 blue markers. They're probably all the same. So 3 blue times 2 red times 5 green. Now, the reason I set it up this way is because I have 2 red, I have 3 blue, and I have 5 green. So when you write it that way, maybe it's easier to see that I have a total of 10, but these 3 are repeated, these 2 are repeated, and these 5 are repeated. So I'm going to enter this, and I got 2,520 ways that markers can be distributed. That is the end for that video.